Dear students, we continue our lecture. We saw before in the previous videos that human is the heart of information system. But we saw also that this role of human is being changed. Last century, we invented a lot of technologies. For example, the computer. The computer can treat the data. We invented also the high-level programming languages. These languages permitted any human, to write programs to treat data. We invented also database management system to treat a huge quantity of data in the computer. We saw that the communication tools and protocols are developed. We used internet. So all these technologies have its impact on human, on the role of human and sensor in an information system. So before human uses his senses in order to get the data. After that, he analyzes the data. For example, with traditional temperature meter, human read the data directly with his eye. But with the development of technology, the sensor communicate directly with machine, and the human communicate also with machine. It is not necessary to be the same machine. So the human may be far because there is a communication network. Usually people say Internet of Things. Internet of Things has a formal definition regarding this diagram, because in Internet of Things every object, everything has its IP. But in general, this is the eventual situation of sensors. In general now, sensors communicate usually with some components, not directly with the human eye. And this data that is sent by a sensor is stored digitally. Last century we used electronic technology to see sometimes directly the sensor, what sensor do, and how it sends the data. Changed the role of a human and sensor. So now we don't use anymore the senses most of times to read the sensors, but to communicate with the machine. So the type of interfaces changed. The direct communication between sensor and machine is widely extended. The types, values of the parameters of the environment that we measured. Before, we were limited by the senses, the 5 senses of human that can capture the data. We are limited by the quantity of this data, by the frequency of this data. Now, the sensor, we can say that the sensors are free. So we have now a huge quantity of parameters that we can measure. We couldn't measure them before. For example, ultrasonic. We are limited by our 5 senses, but with machines, there are wide range of values that we can measure and wide range of parameters that we can measure. What is important also, that it is not necessary that we communicate with the same machine, because the communication technology is developed, and most of time anywhere on the earth we can communicate with a communication network, and we can communicate with a machine that reads a value of one sensor. So what happened now? Do we use anymore this traditional meter? No, we don't use anymore this traditional meter, but we should use always our 5 senses, not to communicate directly with the temperature meter, but to communicate with machine. Fortunately, we developed a lot of tools, a lot of programs, a lot of interfaces to facilitate this communication. A lot of scientists worked in this domain to make this communication natural as much as possible. An example about the wide range of sensors that we can use today. You can log into Wikipedia and search list of sensors on Wikipedia. We will look together and you will see list of sensors. This is only some examples. So here are the types. There is a lot of sensors that measure the sound, but these sensors that measure the sound may be used everywhere. For example, geophone. What is geophone? It is a sensor that is used to measure the movement of the earth, and as you see here, it is for earthquake. So a geophone is a device that converts ground movement into voltage, which may be recorded at a recording station. So this is an important sensor. We go to the next one. It is also acoustic, but it is used in water. Hydrophone. So it depends on the same principle, but it is developed to be used in another place. We have also the microphone. You know the microphone. So you can search in this list and you will find a huge quantity of sensors. If we want to make use of the technology today to create our own information system, it would be a good idea to check the type of sensor that match with our system. We will not waste a lot of time here, but perhaps I will ask you some questions later to check this type of sensors and to find some sensors with a specific profile. So we continue. This is another example. Now if I log into the internet and I write Meteo New York, for example, I will find that the temperature eventually now is 7. In Bangkok, for example, it is 30. In Beijing, it is 10. In another city that is very cold in Russia, it is minus 20. And we can see also a type of graph that show us the difference between night and day. This interface is user-friendly interface that facilitates the understanding. So we have sensors everywhere in the world, and these sensors are connected directly to machines, and these machines are connected over the globe. And everywhere over the globe, I can connect to the internet, and I can read using the platform of Google. I can read easily these types. That this reading is easier than reading the traditional temperature meter. So all types of sensors now give a lot of types of information and a lot huge quantity. We talked about Internet of Things, and we said that there is perhaps 20 billion sensors around the world, and all these data are registered somewhere, and a huge quantity of these data are open source, so we can log and we can make use of these data. So perhaps if we need some types of data in our information system, these data may be somewhere, may exist somewhere around us. 3 years ago, we needed some data about the gases here, about the meteo station, about the air quality. So we used some sensors. It costed us almost, we rent them for €2,000 for 2 weeks for the PhD of one of the students. And later we found that there is a meteo station that is not far from here, and it gives this data for free on the internet. So we should develop the sensors. Sensors now should communicate with machine. Even if last century we used electronic sensor, this electronic sensor was able to give data, not digital data, most of the time it is analog data. But now to communicate with the machine, we should send digital data. So the basic sensor is not enough to communicate with data. We should develop this sensor. Most of sensors today can measure one parameter from the environment with a traditional sensor that gives, usually it contains some electronic component that convert the parameter into electronic parameter. After that, we convert it to a voltage. After that, we should convert this voltage into digital value. After that, we send this value to the machine, and the machine can communicate with the network. Why we convert the value into digital value? This is a very important question, because every time we talk about digital, numeric, digital. Why we convert a value into digital value? When we convert it into digital value, we can use all the digital data treatment tools around us, all the computers, to manipulate this data if we have a good program. So when we convert the data into digital data, this value will be able to be registered, to be treated, to be communicated. Nowadays, we use what we call microcontrollers. It is a small electronic circuit. It is like a small microcomputer that enable us to inject small programs, and these programs can convert, can make some treatment, basic treatment of the data that we receive from the sensor. Most of the time, this microcontroller is supported with another blocks, with a memory, for example. A memory, it is not huge regarding the memory of the PC, but it is enough to register a huge quantity of values that we receive from the basic sensor. This data also, we most of time, not always, we can send it by wireless. So we have the necessary hardware component near the microcontroller. We have most of time also we use a battery in order to make this sensor autonomous. So we put all these components in one circuit and we call them smart sensor. Is it really smart or not? This is not our question here, but we should pay attention, as we saw in the first video. What is smartness? The most important in this type of circuits that we convert the value of the basic sensor into digital value in order to be communicated and treated and registered by the machine. As an example of these sensors, we have, as you see, this is a sensor that contains many sensors. There is microcontroller. This is the sensor that I mentioned. It is a sensor that we make in our laboratory here, and we use it in buildings in order to communicate data. We can see, for example, in this sensor, this part, it is a microcontroller. This is a microphone. We use it to register the noisy. The white part, it is a sensor of humidity and temperature. And this part that reflects lights, it is a luminosity sensor. And we put also batteries. And we, as you see, there is antenna, because our sensor can send data for a distance of 50 meters or 20 to 50 meters. So we can use a USB key to receive this data. It is similar to Wi-Fi, not exactly the same, but it is similar to Wi-Fi in order to send small quantity of data, because we need, for sensors, we need a limited quantity of data in most times. For this type of sensors, we send, for example, this temperature. We program this sensor in order to send data every 10 minutes, but we can change also the program in order to send them every 5 or 2 or 3 minutes, or we can program it in order to send the data when there is an important changement in the temperature. Also, we can program it in two directions in order to receive a command from a PC, and when it receives the command, he sends the value of the temperature. But we don't do that in order not to consume the battery. But the most important, that as you saw, this is the basic temperature, or for temperature, the basic sensor for temperature and humidity. The cost of this sensor is of the temperature of it is almost 50 centimes, and this sensor, this smart sensor, costed us almost 50 euro. But if we want to produce it with huge quantities, usually we produce it for 200, 300 units. If we want to produce more, we will have cheaper. It will cost less. Another example, for example, This is another example. We see it is a basic sensor of temperature that we can put underground and we can measure, but we should design the necessary circuit in order to receive these data. We can connect these wires into a microcontroller and we can receive and treat the data. Another example is this one. As you see, it is very advanced sensor. It is, we can say, smart sensor if you want. It is Netatmos sensor. It measures CO2 and the acoustic, temperature, humidity, luminosity. This sensor, as you see, this sensor connects, when we buy it, we can connect it directly to our Wi-Fi in the house, or with the Wi-Fi of our computer or our telephone, and it will send automatically every 10 minutes. It will sense these values: CO2, acoustic, temperature, humidity, luminosity, and where it will use the Wi-Fi in order to connect to the internet, if it is available, and somewhere in the internet, it will stores the data in a database on the cloud, and the user can everywhere over the cloud, if he connects to the internet by his smartphone, he can see the values of the temperature, humidity, luminosity of the sensors, even if it is too far from him. I will show you an examples of these values. For example, on my telephone, I put a lot of sensors everywhere in the city, and I will give you an example. For example, here we can see that it is very friendly user interface. We can see here the temperature, we can see the humidity, we can see the CO2, and it says if these are good or bad. You can see here the values. We can see the temperature, it is excellent, as it says. We can see the humidity, 49%. We can see the ppm of CO2, it is 444. It is very good value, because usually the minimum ppm level, it is almost 400. We can also see the decibel, it is almost 36 decibel. It is about the noise.